Scroll down on the left side menu and click Security Groups. Notice that AWS has been so nice and thoughtful that it created a default security group for our web VPC. Very nice, Amazon, but we want to get into the habit of not using the defaults. So we're going to create our own. Click on Create Security Group, and we'll go ahead and give this a name tag of web-pub-sg, and notice that it automatically fills in the group name with the name tag name. This seems weird at first, but when you consider that a group name is required while a name tag is not, it makes a little bit more sense. I always recommend tagging resources because it makes them a lot easier to inventory later on. Let's go ahead and give this a description of web-pub subnet sg for security group. And we're going to place this in the web VPC and then click Yes, Create. Now, make sure you highlight the group, click the Inbound Rules tab, and then click Edit. And under Type, let's go ahead and select SSH, TCP port 22. And for the source, I'm going to put my IP address, 2496.154.171/32. And the /32 indicates that it's going to be good for only this one particular address. The description is me, and let's click Add Another Rule. This is for HTTP traffic, TCP port 80, and we're going to allow this traffic from anywhere on the IPv4 internet, the world. Okay, let's go ahead and click Save. Next up, we're going to create an elastic network interface. Let's go to Services, click on EC2, scroll down on the left side menu until you see Network Interfaces and click Network Interfaces, and then click Create Network Interface. For the description, let's put www1 eth0. The subnet is going to be web-pub. And notice under private IP it says auto assign. We could let AWS assign an IP address in the web pub subnet if we want, but I don't like random IP addresses. We want the IP address to be meaningful, and we've already decided what it should be, which is 10.1.254.10. Finally, go ahead and select the security group we just created, web-pub-sg, and then click Yes, Create. Now notice that even though we've got a description, we don't actually have a name tag. So let's go ahead and hover the name field, click the pencil icon, and we'll type www1 eth0 and click the check mark. Now if you scroll over to the right and look under IPv4 public IP, notice that there is no public IPv4 address assigned. We want the instance to be publicly accessible on the internet, so we need to assign an elastic IP. But before we can assign one, we have to allocate one. Let's go do that. On the left menu, click on Elastic IPs, click Allocate New Address, and then click Allocate. And then once it allocates an address, click Close. Now go ahead and click on the address it just allocated, go to the Actions menu, and click Associate Address. Now under Resource Type, you want to click the Network Interface Radio button, select the network interface we just created, and under the private IP, select the only private IP address assigned to the interface, which is 10.1.254.10, and then click Associate. Tells us that it succeeded. Click Close. Now on the left side menu, scroll up to Instances, click Instances, and then click Launch Instance. Go down to Community AMIs, click that, and under Search Community AMIs, we're going to search for a very specific image. It's going to be AMI-1CB6B467. Now this particular image is one of the later Amazon Linux AMIs, which includes Docker. And we want this because we're actually going to use Docker to spin up our web server later on. And by the way, if you're a Windows person, I don't want you to feel left out here. The concepts we're going to cover apply to Windows and Linux equally, so don't worry about that. I'm going to go ahead and select this image here, click Select, and then for the instance type, I'm going to select T2 Micro, click Next, Configure Instance Details, and then under Network, we're going to select the Web VPC, and then just make sure Web Pub is selected under the subnet. Now, Scroll all the way down to Network Interfaces, and notice that we have an ETH0 interface. Look in the drop-down under Network Interface, and you should see the Elastic Network Interface you just created a few moments ago. Go ahead and select that, and notice it says we can no longer assign a public IP address to your instance. This is a little bit misleading. What this means is that because we've selected an existing ENI, AWS is not going to attempt to automatically assign a public IP address. But AWS would not have assigned a public IP address regardless. Why not? Well, when you create a new subnet, by default, AWS will not assign public IP addresses to instances in that subnet. Okay, that's it for this screen. Click Next, Add Storage. And the defaults are fine here, so click Next, Add Tags, and then click the Add Tag button. Under Key, type name with a capital N, case does matter here, and the value is www1. Next, click Configure Security Group. Select the radio button next to select an existing security group, and then go ahead and tick the box next to Web Pub SG. And there you go, we can see the security group that we created a little bit earlier. Click Review and Launch. Give everything the once over, make sure it all looks good to me, and then click Launch. Now it's going to ask us to select an existing key pair or create a new key pair. I have one I've already created. I already have it, so I'm going to click the checkbox, acknowledge that I have access to it. You can create one here if you need to, and then click Launch Instance. Once you see this, go ahead and click on the instance name here. And then down at the bottom right where it says IPv4 public IP, I'm going to go ahead and highlight this IP address, copy it to my clipboard, and then I'm going to jump over to my SSH client and SSH to this address. I'll go ahead and connect using the username EC2-user, and then paste in the IP address here. It asks if we want to trust this particular key. I do want to trust it. And we're in. Now, if you've brought up Linux instances before, this should look very familiar to you. Notice we have the private IP address displayed in the prompt here, 10.1.254.10. Now remember, earlier I said that AWS uses the first IP address of the subnet, in this case .1, as the IP address of the implied router. And yes, you can ping this router. Let's try it. Ping 10.1.254.1. And yes, indeed, it is reachable. Now let's see if we have internet access. Let's try pinging Google 8888. And that works. And, you know, we could just leave it at that and move on, but this is a networking deep dive. We want to understand not only how this works behind the scenes, but why Amazon designed its virtual network architecture the way that it did. If you've been in IT for a while, you've undoubtedly run into situations where something as simple as pinging a host on the internet does not work. When that happens here in the cloud, you need to have a clear step-by-step understanding of exactly how traffic gets from this instance out to the internet, and that is what we're going to cover next.